is kinematic equation for uniformly accelerated motion. ठीक है? Kinematic equation, kinematics क्या होता है? See, what you are studying is mechanics. Okay, the chapter motion, force and laws of motion, gravitation, work and energy. All these chapters come under mechanics. Mechanics is a branch of physics where we talk about motion of objects. Okay, where we study acceleration, where we study motion, speed, velocity, displacement, these kind of quantities we discuss. Okay, so in mechanics, we divide mechanics further into sub branches. Okay, so one of the branches is kinematics, and the second one is dynamics. Kinematics is the branch of mechanics where we talk about motion of the objects, but we do not consider the cause producing the motion. How is state of motion of an object changed when we apply force on the object? If the object is at rest, it starts moving. It may or may start moving. And if the object is already moving and we are applying force on the object, then we may or may not stop the object. It depends upon the strength of the force with which we are trying to stop the object. If the force is sufficient enough, only then we can change the state of motion. Otherwise, we cannot change the state of motion, right? So where we talk about cause producing the motion, and cause producing the motion is force. So when we include force, then it becomes dynamics. We call that branch of mechanics as dynamics. Okay, so kinematics में we do not consider force. We only consider the velocity, we only consider acceleration and distance travel time taken by the object. And in dynamics, we also consider force producing the motion, or force producing the acceleration, and force responsible for the change in velocity of the object. Okay, change in state of motion of the object. So the second chapter of physics. In the second chapter of physics, we will do force also. We will cover force. Okay. So wahan pe we talk about that we have applied this much force on the object and it is accelerated. Its velocity has changed from this to that. Okay. But in this chapter, we are dealing with only motion. So kinematic equation for uniformly accelerated motion. Uniformly accelerated means that acceleration is constant. We are assuming that there is no change in acceleration. Okay. So kinematic equation for uniformly accelerated motion. So we have this graph. Look at this graph. So what does this graph represent? Look at this line, this BC at B. So when the object is at B, then it is at rest. No, it is not at rest. When the object is at B, at this point, look at the cursor. See, the velocity component is not zero. It is a velocity time graph, right? And this graph is BC. BC is a straight line. This graph is BC. Okay, and BC is a straight line. So this graph represents uniform acceleration. In VT graph, when we draw a straight line inclined to time axis, it shows uniform acceleration. So at time t equals to 0, yes. At time t equals to 0, at this time, what is the velocity of the object? It's u. Okay, this. What are the coordinates of point B? Tell me. 0 u. At time t is equal to 0, velocity is u. And at time t, velocity changes to b. Okay, धीरे धीरे आएगा समझ, don't worry. At time t, velocity changes to v. So there is a change in velocity, and velocity is changing by equal amount in equal intervals of time. And therefore we say that it is a uniform. It is in uniform acceleration. Okay. So let's consider the terms. Displacement is s. We denote displacement by s. We denote time taken by t. We denote initial velocity as u, and we write final velocity as b, and we write acceleration as a. So these are the notations that we use. Okay. So, and the three kinematic equations for uniformly accelerated motion are V is equal to u plus at, where V is the final velocity. This equation is called velocity time equation. And this is the second equation where we find displacement S, and it is equal to ut plus half at square. Ut plus half at square. Okay, and the third equation, here we find final velocity in terms of initial velocity, acceleration, and displacement. So it's v square is equal to u square plus 2as. So these are the three kinematic equations that we'll be studying. We are going to derive these equations. In today's session, we are going to derive these three equations. Okay, so it's v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. So let's assume a situation. Suppose initially we have an object. Consider a situation. Suppose initially we have an object. Okay, this is the object. And this object is at rest, is moving. It is not at rest, it is moving. So at the time we have started observing the object, this object is moving with velocity u, let's say. So u is the initial velocity of the object. And we at this point, we are considering time as 0. At time t equals to 0, object is moving with velocity u. Okay. So after some time, it covers a certain distance in time t. This object covers a certain distance in time t. Let the distance covered by the object is s. And its velocity becomes v at t. Its velocity is v at time t. Okay, so there is a change in velocity. And object is covered certain distance. So we say because there is a change in velocity and therefore object is accelerating. And how do we write acceleration? It's v minus u upon t. This is how we write acceleration. Okay. So this is acceleration. It is v minus u by t. So ये हम situation consider कर रहे हैं. On this basis, we are going to derive the all three equations of motion. And for this, see, for the derivation, we will use the graph. We will be deriving these equations using graph. We can also derive this equation using this formula. Also, the first equation can be derived directly from this formula. Move this t to the other side, and then this v minus u becomes at. Yes, v minus u becomes at. Now move the u to the other side, it becomes v is equal to u plus at. So we can derive like this also. But in your exams, they ask you to derive the equations of motion using graph, using velocity time graph. Okay. So this relation v is equal to u plus at. In this relation, we have only velocity and time. So sometimes we call this as velocity time relation also. So when we say it's velocity time relation, then it's first equation of motion. This is first equation of motion. Okay. First equation of motion. Okay. And when we say position time relation, position is s, the displacement, and time is t. Then we write s is equal to ut plus half at square. Either they ask you to derive position time relation, or they can change the statement and they can ask you to derive second equation of motion. Okay, so this is second equation of motion. It is also called as position time relation. And third equation of motion is position velocity relation. Position velocity relation. Here you can see we have only velocities, initial and final velocity, and the displacement. So it is called position velocity relation, and this is the third equation of motion. Okay, this is the third equation of motion. So these are the three equations of motion that we have. And one more thing, look at the quantities that are given. On the basis of this, we can plot the graph. So let's plot the graph. This is your x-axis. This is your y-axis. And where do we take time? Where do we write time? We write time on x-axis. Why on x-axis? Because it is an independent variable. Independent variables are always written along x-axis. And velocity, we write along y-axis. So velocity we write here. Let's say we are measuring velocity in meter per second and time in seconds. Okay. And this is origin. Write x, y. Okay. So at time t equals to 0. At time t is equal to 0, we are assuming the velocity to be u. T is equal to 0 is the time at which we start observing the object. So velocity is u at this time. This is u. So this distance is u. We can write this, this origin to this part as u. Okay. And so after some time, velocity of the object at time t, let's say, velocity of the object changes to v. So v is this much from origin to this point is v. This is v and this is u and this is t. Okay, because object is uniformly accelerating, so graph is a v. So the graph is like this. So at time t equals to 0, velocity is u, and at time t equals to t, velocity is v. After time t, velocity of the object is v. Yes. This is how we draw the graph. Now using this graph, we can find displacement and acceleration. Because from VT graph, we get two quantities. One is displacement and other is acceleration. We get displacement by finding area under curve, and we get acceleration by finding slope of the curve. This is how we find these quantities from VT graph. Okay, so for acceleration, we need coordinates because we do V2 minus V1 upon T2 minus T1, right? So what are the coordinates of this point? This is 0 and u, and coordinates of this point T and V. So now we got the coordinates. We can easily use the formula V2 minus V1 upon T2 minus T1 for acceleration. And similarly for displacement, we need to find area. And you can see we have displacement in these two, the second equation and in the third equation as well. So in the second equation, we have this S. In the third equation also, we have this S. Okay, so in both the equations, we will find area under curve. While in the first equation, we will find slope of the curve graph. Okay, so area under curve. How do we find area under curve? So this is the area line, and area under curve is the region, area of the region occupied by the graph, the curve, and the x-axis. This is area under curve. Now look at this. It looks like a trapezium. We have two parallel lines. Yes, opposite lines. You can see this line and this line. They are parallel. So it looks like a trapezium. So we can find area of the trapezium to get area under curve. And we can do one more thing. We can also find area by dividing this figure into two parts. And we can separately find the area of this triangle first, and then area of rectangle. On adding these two, you get area under curve. So there are two ways of finding area under curve. One, by finding area of the trapezium. If we find area of the trapezium, we'll get area under curve. And second is by finding area of triangle and area of rectangle separately and adding them, we can find area under curve. So when we will derive second equation, then we will use this triangle rectangle thing. And when we will derive the third equation, for deriving third equation, we will use the trapezium, area of the trapezium. Okay, this is what we have to do. First equation of motion is velocity time relation. Here we relate velocity and time. So it's v is equal to u plus at. Okay. Okay, so v is equal to u plus at is the first equation. What is acceleration? Acceleration is change in velocity upon time.
Selection commission.
Acceleration is change in velocity upon time, and change in velocity is v minus u. Okay, change in velocity is v minus u. So v minus u upon t. We can write like this. Okay, so from here we get at is equal to v minus u because it transpose हो जाएगा at will go to the other side, and therefore v is equal to u plus at. This is the first equation of motion. See, we can also write this as, because acceleration is slope of vt. Yes. And how do we take slope? At time t equals to 0, object is moving with velocity u. And after time t, at t we can say its velocity changes to v. It covers a distance s in this time interval and acceleration is v minus u. This is the situation. Okay, so how do we find slope? For this we need to fix the coordinates. So let's write the coordinates of this point B first. It's 0, u. Because this is u, na? This is u, and this is, and coordinates of this point. This is t. So abscissa is t, and ordinate is this v. So now we can take the slope. This is your x1, y1, and this is your x2, y2, and slope is y2 minus y1 upon x2 minus x1. Okay, and y2 minus y1 is v minus u, x2 minus x1 is t minus 0. So we can write like this. Now you can simplify this and you will get this v minus u as at, or v is equal to u plus at. This is how we write the solution. Derivation. This is derivation of first equation of motion. Derivation where we derive the formula. Derivation करते हैं हम physics में, जहाँ पे हम formulas को derive करते हैं, and then we use this formula wherever we want. For example, if time, acceleration, initial velocity is given, out of then we can find final velocity. So out of 4 quantities that we have here, final velocity, initial velocity, acceleration, and time, 3 quantities will be given, and you have to find the 4th one. Okay, write this now. Next, we have second equation of motion. This is the position time relation. Here you can see we're relating the position with time. It's s is equal to ut plus half at square. So again, we have the same graph for this. Okay, because we have to find the displacement. So we can get the displacement by finding area under VT graph. Okay, so for this we need to divide this triangle into this area under curve into two different shapes we have here. One is triangle, other is rectangle. So we will simply find the area of triangle and rectangle separately, and then we'll add them to get the total area. This is what we are going to do. Okay, so OA is T and BD is also T because OA and BD are equal. Both are equal to T. And OB. OB is this much distance. This is U, na, initial velocity. And what is your OF? OF is V. OF is V and OB is U. So we can find BF. BF is OF minus OB, it's V minus U. And because BF is V minus U, so is CD. Because BF and CD, they are equal in length. And BF and CD are equal in length. So if BF is V minus U and therefore CD is also V minus U. Clear? So because we know that A is V minus U by T and therefore we can write V minus U as AT, we'll be using this relation. In this derivation, we will use this relation. V minus U as AT, where we'll see now that there is V minus U. There we will write AT in place of V minus. Okay. So we find displacement by finding area under VT graph. Okay. So area of this shape is area of this rectangle plus area of triangle. Area of rectangle is length into breadth, OA into OB. Yes, you're right. OB into OA into OB. And area of triangle, this is a right angle triangle. Half into base into height. So base is BD and height is CD. Okay. So now we will write for OA, we can write T. For OB, we can write U. OA is T, OB is U, CD is, no, CD is equal to BF and BF is equal to OF minus OB. Yes, V minus U. And what is V minus U? It is 80. V minus U is 80. So we'll get this equation. S is equal to UT plus half AT square. This is the second equation of motion and it relates position with time. Okay, this equation relates position with time. Any doubt in this? ये आपका जो V है ना, ये पूरा V है, यहाँ से लेकर यहाँ तक यू हैव V. And U is this is U. And this is your T. Next is the third equation. The third equation of motion is V square minus U square is equal to 2AS, and it relates position and velocity. So you can see that here we do not have acceleration, है ना? Sorry, we do not have this time variable here. We only have velocity, position, and acceleration. So we have displacement. So where we have displacement, there we take area under curve. Only then we get displacement. This is the only way of getting displacement. Okay, so here we have S, so we'll find area under curve in this derivation also. And but this time, instead of dividing this into 2, we will directly find the area of trapezium. Okay, so displacement is area under VT graph, and area under VT graph, so we'll instead of taking triangle and rectangle. In the previous section, we have divided this into 2 parts, triangle and rectangle. Now we are considering this figure as one figure, and this is a trapezium we can see because OB and AC are parallel to each other. So we can find area of trapezium. How do we find? Distance between the parallel sides. And parallel sides that we have here are OB and AC. OB is parallel to AC, na? OB and AC are the parallel sides. So we'll add these two parallel sides, and distance between these two parallel sides is distance between the parallel sides is बताओ? Sorry. BD. Yes, you're right. BD is the distance between the parallel sides. So if we have a trapezium, let's consider this trapezium as O, A, C, B. Okay. And this is the perpendicular distance. This is the perpendicular distance. So instead of considering the same variables, let's choose another variables that we do not have in this graph. So let's take PQRS. Different variables we are choosing. Let's not create confusion. No? Let this be M. Okay. So parallel sides are PQ and SR. These are the parallel sides. And distance between the parallel sides is SM. Is the perpendicular distance between the parallel sides. So area of trapezium PQRS is equal to half into sum of parallel sides PQ plus SR into distance between the parallel sides is SM. This is the formula finding area. Area of trapezium using the same relation. So the parallel sides are V AC, na? AC is the parallel side. AC and OB. Yes. And AC is equal to OF. So it's V plus U into T. So for T, we can write this. On solving this, you will get this relation. This is the third equation, okay? And see, what we have done here is, we have, see this thing, V is this much, sorry, this much. And U is OB. T is this, right? So this is your V. This part OB is U, and this OF. OB is U and OF is V. And because OF and AC are equal in length, this implies AC is also equal to V. OA is T. OB is U, OF is V, and OF and AC are equal. So both are equal to V, and OA is T. OA is the perpendicular distance between the parallel sides. And parallel sides are OB and AC. है ना? Area of trapezium is sum of parallel sides half into OB, sorry, OF plus, no, sum of parallel sides we have to find, right? Okay, it's OB plus AC into the perpendicular distance between the sides. OB is U and AC is equal to OF, and therefore it is also equal to V, and OA is T. So it's half V plus U into T, and T is V minus U by A. How? How come? Because A is V minus U by T. So we can write T as V minus U by A. Now here we have used the identity. Which identity we have used here? A plus B, A minus B. A plus B, A minus B is A square minus B square. So A is B and B is U. So we'll use this identity and write A B square minus U square. अब क्या किया हमने? B square minus U square. So we have S is equal to, from here we have S is equal to B square minus U square upon 2A. So we can move this 2A to the other side. We'll get this relation as B square minus U square is equal to 2AS. Okay. Anything you want to ask? Kinematic equations are applied for a uniformly dash motion. Circular, retorted, decelerated, accelerated. Accelerated is the correct answer. Next, now we have a numerical based on this. A bus starting from rest moves with uniform acceleration of 0.1 meter per second square for 2 minutes. Find the speed acquired and the distance traveled. So here we have to use the 3 equations of motion that we have discussed. And using those equations, we will find the things which have been asked in this question. Okay. So a bus starting from rest. Starting from rest means, first we'll write given. Starting from rest means? No, starting from rest. Object was at rest initially. Bus was at rest initially. So starting from rest means initial velocity of the bus is 0. So initial velocity comma U is equal to 0. And with uniform acceleration. Acceleration is given. Acceleration A is equal to 0.1 meter per second square. For 2 minutes, time is given. Time T is equal to 2 minutes. See, whatever we have, you can see that acceleration is in meter per second square. That's SI unit. But this minute is not in SI. So we need to convert this into second first. It's 2 into 60 second, 120 second. Now to find, we have to find the speed acquired. Speed acquired means we need to find the final velocity. Final velocity, and second, distance traveled. Distance traveled is S. See, we have to find out U, A, and T are given. So we can write the first equation because that equation relates all these four quantities. So using the first equation of motion, using the first equation, we need to write this every time we are using the relation of motion. We get it's V is equal to U plus AT. Now put the values here. U is 0, A is 0.1, and time is 120 seconds. So this is 12 meter per second is the answer. Okay. Next we have to find is the distance traveled. How do we find the distance? How can we find the distance? Using second or third equation, any equation can be used. In second, if you use second equation, it's S is equal to UT plus half AT square. So we have the variables, values. And if you use third equation, V square minus U square is equal to S, again we have the all the values. Okay, so let's use third equation. Third equation of motion we get, it's V square minus U square is equal to 2AS. So we can write S as V square minus U square upon 2A. Now we'll put the values here. V is 12 meter per second. This is what we have got, right? And U is 0. 0 square upon 2 into A is 0.1. So 12 square is 144 upon 2 into 0.1 is 0.2. So we can write this as 144 upon 2 into 10. We can write in the numerator. 2 ones are 2, 2 sevens are 14, 2 twos are 4. It's 720 meter. This is the distance covered. So you can enclose your answers, in the box. Write the answer, final answer as this. V is equal to 12 meter per second and S is equal to 720 meter. Enclose your answer in the box. A train is traveling at a speed of 90 km per hour. So we'll write given. This is the initial velocity of the train which is given. Yes. Initial velocity. See, मैं क्वेश्चन कैसे रीड कर रही हूँ देखो. मैंने अभी पूरा क्वेश्चन रीड किया. नहीं किया ना? क्या रीड किया? Just one sentence. This is how we should read. अगर हम बहुत सारा पूरा क्वेश्चन एक बार में रीड करते हैं तो we get multiple instructions. उससे confusion create होती है. फिर लगता है ये क्या हो रहा है हमारे. ठीक है? Always read in parts. A train is traveling at a speed of 90 kilometers per hour. So we can convert kilometer per hour into meter per second just simply by multiplying this by 5 by 18. 5 by 18 into 90 meter per second. And in the table of 18 we get 90 as 18 fives are no 18 fives are 90, yes, 25 meter per second. Brakes are applied so as to produce uniform acceleration. The acceleration is given. It is negative. Why is acceleration negative? Because we have applied the brakes and velocity will decrease. How far the train will go? How far the train will go means we have to find the displacement before it is brought to rest. Brought to rest matlab final velocity is 0. Final velocity v is equal to 0. Okay, to find displacement. Yes, commas. Okay, solution. Which relation should we use here? But we do not have time. We can't use second equation of motion for this. We need time also. So first we have to find time and then we can apply second equation of motion. Yes, we can do that because T is V minus U by A and V minus U by A and S is equal to UT plus half AT square. That can be done easily. Is there any equation, direct equation which can be used here? Tell me. Third equation, yes. Yes. So let's use third equation. Third equation of motion. Third equation of motion is v square minus u square is equal to 2as. S is equal to v square minus u square upon 2a. Now put the values here. V is 0, 0 square minus u is 25, 25 square upon 2 into minus 0.5. Okay, so what will we get? 25 square is 625, right? Square of 25 is 625, so minus 625 in the numerator. And in the denominator, we have this 2 into 0.5, it's minus 1. No? 1, negative, negative, cancel each other, and we are left with this 625. Therefore, displacement or distance covered by the train, distance covered by the train before it is brought to rest is 625 meters. Okay. A train is traveling at a speed of 90 km per hour. So we'll write given. This is the initial velocity of the train which is given. Yes. Initial velocity. See, मैं क्वेश्चन कैसे रीड कर रही हूँ देखो. मैंने अभी पूरा क्वेश्चन रीड किया. नहीं किया ना? क्या रीड किया? Just one sentence. This is how we should read. अगर हम बहुत सारा पूरा क्वेश्चन एक बार में रीड करते हैं ना तो we get multiple instructions. उससे confusion create होती है. फिर लगता है ये क्या हो रहा है हमारे साथ. ठीक है? Always read in parts. A train is traveling at a speed of 90 kilometers per hour. So we can convert kilometer per hour into meter per second just simply by multiplying this by 5 by 18. 5 by 18 into 90 meter per second. And in the table of 18 we get 90 as 18 fives are no 18 fives are 90, yes, 25 meter per second. Brakes are applied so as to produce uniform acceleration. The acceleration is given. It is negative. Why is acceleration negative? Because we have applied the brakes and velocity will decrease. How far the train will go? How far the train will go means we have to find the displacement before it is brought to rest. Brought to rest matlab final velocity is 0. Final velocity v is equal to 0. Okay, to find displacement. Yes, commas. Okay, solution. Which relation should we use here? But we do not have time. We can't use second equation of motion for this. We need time also. So first we have to find time and then we can apply second equation of motion. Yes, we can do that because t is v minus u by a and v minus u by a and s is equal to ut plus half a t square. That can be done easily. Is there any equation, direct equation which can be used here? Tell me. Third equation, yes. Yes. So let's use third equation. Third equation of motion. Third equation of motion is v square minus u square is equal to 2as. S is equal to v square minus u square upon 2a. Now put the values here. V is 0, 0 square minus u is 25, 25 square upon 2 into minus 0.5. Okay, so what will we get? 25 square is 625, right? Square of 25. is 625, so minus 625 in the numerator. And in the denominator, we have this 2 into 0.5, it's minus 1. No? 1, negative, cancel each other, and we are left with this 625. Therefore, displacement or distance covered by the train, distance covered by the train before it is brought to rest is 625 meters. So we have a trolley. While going down an inclined plane has an acceleration of 2 centimeter per second square. So acceleration is given. It is 2 centimeter per second square. What will be its velocity 3 seconds after the start? After the start means initially trolley was at rest. So we can take initial velocity as 0 because it is written after the start. After the start means initial velocity is 0. And what will be its velocity? 3 seconds. Time is given. Time is 3 seconds. Okay. So quantities which are given to us are u is equal to 0. T is equal to time is equal to 3 seconds. Okay. And acceleration is 2 centimeter per second square. So no need to convert this acceleration into meter per second square. We'll get a velocity in centimeter per second. Yes. So what we have to find is we have to find what will be its velocity. V. We have to find V. Which relation we can use here? Yes, very good. First equation of motion. And first equation of motion is V is equal to U plus AT. Now put the values here. U is 0, A is 2, and time is 3. So our answer is 6 centimeter per second. This is the final answer, and close your answer in the box. A racing car has uniform acceleration of 4 meter per second square. Acceleration is given. It is so given acceleration is 4 meter per second square. What distance will it cover? What distance will it cover? Means we have to find displacement in t seconds. Sorry, in 10 seconds. Time is given. Time is 10 seconds after start. After start means u is 0. After start means u is 0. So we have to find distance. Now tell me, what should we write now? Which equation?
Second.
Very nice. Second equation of motion. So S is equal to ut plus half at square. Now put the values. U is 0, t is 10, plus half a is 4, t square is 10 square. So this is 0 plus 2 ones are 2, 2 twos are 4, 2 into 100 is 200. This distance covered is 200. S is equal to 200 meter. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. So write given. It is thrown in upward direction. So this is the initial velocity of the stone. It's 5 meter per second. U is 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, negative ho jayega. Because see, stone is moving in upward direction. So this is the direction of motion, and acceleration is acting in downward direction. This is the direction of motion of the stone. And acceleration is acting in downward direction, opposite to the direction of motion. So if acceleration acts opposite to the direction of motion, then we take a negative sign. So we'll take minus 10 meter per second square in the downward direction. What will be the height attained by the stone? We have to find height and how much time will it take to reach there at the highest point. See, at the highest point, velocity is 0. So initial velocity is given, it is 5 meter per second, right? And acceleration is acting in downward direction. This is also given. And we have to find the height attained by the stone. Height attained by the stone, let this be the maximum height attained by the stone, h. Okay, h is the height attained by the stone and time it takes is t. At highest point, velocity of the stone becomes 0. So this is the final velocity of the stone. Okay. So final velocity of the stone is 0. Now we have to find highest point. So S is equal to H. Height attained we have to find out. Distance covered is the height of the stone and time.
First,
Hmm?
first equation.
See, first we need to find this S and then time. You can use, yes, you can find time first and then displacement. There is no harm in finding like this. But let's go step by step. What will be the height attained by the stone? For height, we need to find this S and V, U and A are given. So we can use third equation of motion and as V square minus U square is equal to 2AS. In the bracket, we will write third equation of motion. This implies S is equal to V square minus U square upon 2 into A. Now put the values here. V is 0. 0 square minus U square is 5 square upon 2. A is minus 10. So it's minus 25 divided by minus 20. Minus minus cancel. 5 5s are 25. 5 4s are 20. It's 5 by 4. Now again we will simplify this. 4 1s are 4. 4 1s are 4. Remainder is 1 1 0. 4 2s are 8. Remainder is 2 2 0. 4 5s are 20. 1.25 meter is the height attained. And second thing that we have to find out is time, right? So as V is equal to U plus 80, now here we'll use first equation of motion. In the bracket, we will write first equation of motion. This implies T is equal to V minus U by A. Now put the values here. V is 0, U is 5, and A is minus 10. Minus minus cancel. So we'll get minus 5 by minus 10, right? Minus 5 by minus 10 is 0.5 seconds. Now write the final answer. S is equal to 1.25 meter and T is equal to 0.5 second. And close your answer in the box. A ball is gently dropped from a height of 20 meter. So height is 20 meter. So let this as H. This is 20 meter. And ball is dropped from this height. Okay. A ball is gently dropped from a height of 20 meter. If its velocity increases uniformly at the rate of 10 meter per second square. ये तो कर नहीं लिया? Okay. Okay, let's do this then. If its velocity increases uniformly at the rate of 10 meter per second square. With what velocity will it strike the ground? Let V be the velocity. V is the final velocity, right? So let V be the velocity with which it strikes the ground. Okay. See, when we throw an object from a certain height, then it's a case of free fall, right? It's a case of free fall. Object is falling freely under the action of gravitational force. So initial velocity of the body we take as 0. Now the question is that after what time will it strike the ground? So we have to find time. Okay. So in this question we have S or H, we can say, S is equal to H, height of the, this building, or what height is given, right? It's 20 meter. U is 0. A is 10 meter per second square. We have to find with what velocity will it strike the ground, means we have to find velocity, and after what time will it strike the ground. We have to find final velocity and time. Okay, so how will we find? See, first we will apply third equation of motion here. So solution. Third equation of motion is V square minus U square is equal to 2AS. Okay, so V square, because V square, this implies V square minus, and this U square, it is 0 square is equal to 2, A is 10, S is 20. So it's 400. So this implies V is equal to root 420 meter per second. And velocity with which it strikes the ground is 20 meter per second. Okay, now we have to find time. How can we find time? Which equation should we use? Second or first or third? We can use first equation. We can also use second equation, S is equal to U2 plus RPT square. Let's take first equation. First equation is V is equal to U plus AT. In the bracket, we should always write that this is third equation of motion. And this is first equation of motion. Okay. So this implies T is equal to V minus U by A. Now put the values here. V is 20, U is 0, and acceleration is 10. So time it takes is 2 seconds. So it strikes the ground after 2 seconds. Okay. Therefore, now we've got the answer. V is 20 meter per second and T is 2 seconds. Enclose your answer in the box. A train starting from rest. Starting from rest means? Yes, initial velocity of the train is 0. So we'll write given. Initial velocity of the train is 0 because train is starting from rest. U is 0. Attains a velocity of 72 kilometer per hour. This is V. In 5 minutes. This is T. Let's write this. V is 72 kilometer per hour. And time is given. It is 5 minutes. 5 minutes. Assuming that the acceleration is uniform. See, acceleration is uniform, so we can apply the 3 equations of motion that we have studied. Okay, find the acceleration. To find acceleration, number 1, and number 2, distance traveled by the train. Distance traveled by the train for attaining this velocity. Distance traveled by the train for attaining this velocity. This is the complete question. Solution. For A, which equation should I use here? V, U, and T are given. First equation, so we can directly write A is equal to V minus U by T, because acceleration is rate of change of velocity with time. Yes. So put the values. First, we need to convert this. It's 72 km per hour. 72 km per hour is equal to 5 by 18 into 72 meter per second. So we'll get 20 meter per second. Yes. And time is 5 minutes. 5 minutes is 5 into 60 second. So it's 300 second. Now put the values here. So V is the final velocity. It is 20 minus 0 upon T is 300. 2 by 30. 1 by 15. Answer is 1 by 15 meter per second square. This is acceleration, number 1. And number 2, we have to find displacement. Which relation should we use here? Second or third? We can use third. Second also, ut plus half at square. Third equation can also be used. So let's use third equation of motion. V square minus u square is equal to 2as. In the bracket, we'll write third equation of motion. This implies S is equal to V square minus u square upon 2a. Now put the values. V square is 20 square minus u square is 0 square. 2 into a is 1 by 15. This is 1 for 400. 20 square is 400 into 15 by 2. 2 ones are 2. 2 twos are 4. 200 ho gaya. 15 twos are 30. And this is 3000 meter. So acceleration of the train is, this is the final answer we're writing here. Acceleration of the train is 1 by 15 meter per second square, and distance traveled by the train for attaining this velocity, the velocity which is given is 3000 meter. Now enclose your answer in the box.